Today in my bench I have a Shure SUA-2000A. It's a 2000 watt inverter. Now those type of inverters, those particular models, they came in different designed and different circuits, but this is rather a very interesting unit. The customer who brings this, he said that it got water damage and he took it to a shop, and the technician who worked in that shop, he tried to fix it and he didn't have any luck with it. So let's open it up and see what's inside. When we took a look at the fan, the cooler fan, there is a water damage and rust on the tip of the screws, the holding screws. That typically is an indication of water exposure, because metal tend to rust in this way when it got contact with water. Now I'm going to remove those screws and see what is inside, and if it is capable of to be fixed or not, or it is fixable or not. I'm guessing this is going to be a heavily damaged from the inside, but let's take a look. Here's a look from the inside. As we can see, there is a lot. This design is different from the other models. This is it is a common issue with Chinese product. They always have the same model number, but the inside is a little bit different. Here we have three 30 ampere fuse. That means it's total of 90 ampere. This is roughly can give 1200 watt according to the shopper transistor outside, but depending on the size of those fuses, it can deliver 1000 watt easily. Look at the bending capacitor. Here we have some gunk. This is from the water damage that I previously elaborated. Let's pull this chassis out and see what kind of damage or what kind of work we have to do. After I took the PCB out of the enclosure. Here we can see there is a something did blow up, or in this area over here, and there is water marks in the base of the metal enclosure. This is a look at the part. Those are the MOSFET, and as we can see around here, those has been replaced, and it's apparently there is a, let me just turn in the light first. because apparently here we have a nice little jumper wire. That resistance has been burned, so the idiot made a jumper across it, and these resistance as well, and those are fed from this IC, which is in this case I believe it's the TL 4904, or this is a typical IC for these kind of inverters. Let's take a look from the other side and see if these transistors as well has been replaced. Apparently as so, they has been replaced. Those transistors also has been replaced. Let's flip the PCB around and see. Wow, here we go, it's clearly a water damage, and he replaced those transistors, those two sides, and there is a short here under that diode, and the soldering mask is gone. It's deteriorating as I scratch it. There is a water damage in this area, and he obviously tried to solder these, but apparently he doesn't have enough or a good soldering iron or a good solder in order to do the job right. Let's check the output transistors or the output MOSFET, and what I'm going to do after I've seen all of this, I'm going to pull out all of these transistors and even these, and see what kind of damage has been happened to this, and what is kind and extent of the damage that it is in the driver board around here. Those 4 transistors, as we can see, they control the gate of these MOSFETs. So I'm going to check each one of them, and I'm going to replace this IC and hope for the best. Here's all the MOSFET has been removed. As we can see, he tried to resolder the traces beneath those capacitors, and he typically failed. In fact, he damaged the traces more than they were damaged, and I don't believe that this area has been, maybe it has been corroded, but not torn out like this. This is the problem with people who claim that they can fix these things. If you can't fix it right, don't bother to stuck your nose in it. So I'm going to test all of these and test these 2 capacitors and see either they were low in value or something. But those capacitors, their existence in the circuit is as a filter. So when you hook it up to the terminals to the battery, those receive the charge, and those 2 diodes are for the reverse polarity. So when you reverse polarity and those fuses get popped, this is the main cause. And also these transistors, the diode inside of these two transistors. So I'm going to test these and see which one is the faulty one. After testing these transistors, those are good, the output transistors. The transistor that the earlier has been replaced, those are good, those are bad. So I'm guessing this is an oscillator problem. I'm going to test this circuit over here and see and replace all of those 10 ohm resistors. As we can see, those SMD transistors, they all have the same number. Let's flip this PCB around and see the number clearly if we can. Come on, focus. HY20, HY2D, HY1D, apparently. Oh, those two are HY2D, and these two in the middle, they are the HY1D. And what is the IC number? As we can see, it's KA 7500 BS. This is equivalent to the TL 4094. Apparently those transistors, those two are push-pull and those two are push-pull. So I'm guessing those are the SS 8050 and the SS 8550. So I'm going to pull the schematic or the data sheet on those two transistors, those two numbers, and see which one or who's who, as they say. There is water damage around here. The only problem, if this Ziner was gone, I believe this is a 12 volt Ziner, I'm not sure, but according to a previous designed or previous or similar circuit, basically the circuit and these, they are exactly the same with a few modification, but this Ziner was in a previous set or previous inverter, it was a 12 volt. So, and this is a HY10, but I believe this one is for the low battery shutdown circuit. And these two transistors, they control the fan, or this one, maybe according to the connection. Let's see here, there is obviously a water damage in this area, so I'm going to test. I have a lot of work ahead of me, and I'm going to test each component at the side and see. This is a little bit different. This is the HY3D. 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 So I'm guessing this H3D, it's the MPSA 44. Let's take a look. I have SMDs like these, the original numbers of the SS 8050 and the SS 8550, but not an SMD for this. But I'm going to just clean it up and hope for the best. Of course I'm going to test each component at a side, but apparently this circuit does not have the same problem like that this circuit does. Look at those resistance, and how in the name of God did he think that this resistance, this resistor, it is blown, obviously blown, can pass current or pass power? There's a lot of stupidity. On the other hand, those resistors does not appear to be blown, but I'm going to test each one of them anyway, and if they are not blown, they are going to stay. One other thing, it's very interesting in regarding those suoer inverters, that they always claim what they are not. In a nutshell, they claim that they have a 2000 watt inverter, which is basically the heart of the inverter is the driver circuit and this chopper over here. If you have two of these choppers, I believe you can produce 2000 watt, but in this case, if the cows do fly, this can give or deliver a 2000 watt. So anywho, I'm going to test these and confirm which one of them is shorted and pull the data sheet on them according to the part number or the symbol on the SMD. As we can see, HY2D and HY1D. Whatever that is. I'm guessing the H1YD, it's the MPN ones, and those two are the PMP ones. But let's make sure before we do anything. After taking a look at the data sheet for those three numbers, the HY2D is the SS8550, the HY1D is the SS8050, and the H3D is the A44, as I was expected. So I'm going to pull these transistors out and test each one of these individually and replace this IC and test these resistance and check each one of them separately, and also these capacitors, because in water damage these capacitors are notorious to be fail, and I don't want to blow up my new parts that I'm going to install in this unit. I tested the capacitors, the resistance, the diodes, the zener, and even this transistor, and I pull out these transistors, these driver transistors out, pre-driver transistors out, and there is one. This is the SS 8550. It's burned out, so I'm going to get a new one and replace IC and replace all of these resistors and put the transistor back and assemble it and fire it up and see what happens. As we can see, I clean up the traces and I resolder the positive trace and the negative traces, and I replace this capacitor over here. This one is not giving the right capacity. I clean up these traces as well, as we can see if we zoom in a little bit, that because his idiocy in the soldering, he busted the traces and left them up while he is pulling that transistors out. However, this is the best I could, and this line is good, those resistance are good, this side is, and this line is not good because it got the most damage. Those resistors are okay. I tested them and each one is reading 10 ohms. Now I'm going to replace the resistance in this line and hope for the best. I hook it up and apparently there is no power. After I inspect the positive, that it is feeding the switch, the main switch, this one over here, there is no power on the switch. So I tested the trace of the switch from the bottom side, the downside of the PCB, and I found the trace has been deteriorated. So I'm going to clean this up and hook it up, and then hook it up to the battery, this testing battery over here, and see what happens. I turn it on, hook it up to the battery, turn it on, and the two LEDs has been lighting up, and testing the frequency. This side is giving 33.59 kilohertz, and this side is giving also the same. So I'm guessing this unit is going to work, and it's going to work splendidly. Here's the resistor 10 ohm resistor has been installed. All of these are new transistors, and from the other side I install the old transistors back. Now I hook it up to the battery. I'm going to turn it on for the first time. Okay. Apparently it is working. So let's test it with a multimeter. It's very difficult to do it with one hand. Here is the 250 scale, and okay, good. Let's put it in the enclosure and put some thermal heat paste on these transistors and those two rectifier diode transistors, or in the other term, those two diodes, dual diodes, and hook some load in it and see if it is going to handle the load very well. As a voltage, it's giving relatively a good voltage. The average voltage for inverters is between 180 and the 220 210 volts, so it's giving about 195 volts, which is in range. So I'm going to install it in the cabinet or in the case of it and see what happens. So as we can see, I hook it up to my batteries. Those are 4 ampere batteries for testing 12 volt, for testing purposes only. And I'm going to run my drill, which is a 300 watt drill on it. Let's flip the switch first. As we can see, the green LED is lighting up. It's buzzing because the battery voltage is getting low. Let me get a bigger battery and see what happens. Here's the 55 ampere battery, 12 volts, and I'm going to flip it on. As we can see, the light LED, the green LED is lighting up, and this is a 300 watt drill. Let's check if there is any heat. There isn't any heat whatsoever. So this inverter has been fixed. Sorry. So this inverter has been fixed, and this is the SUA-2000A It's a suoer solar power inverter, pulse inverter, not a pure sine wave. It's a square wave inverter, and they draw it in this figure, and they are very happy because it's giving a square wave instead of a sine wave, pure sine wave. So please, if you like this video, give me a thumbs up, and subscribe, and hit that bell button so you can receive my new videos. Thank you for watching. Catch you next time.